And it's such a long distance, and it takes that light ray so long to reach us that during that time, space has stretched. And so by the time it reaches us, not only has space stretched, but the light ray itself has stretched from being a blue light ray to a red light ray. And if you've heard the word redshift, that's what redshift is. Now that's physically somewhat different from, the ambulance that goes past you and you hear its siren and you notice the change in frequency. The frequency changes depending on in which sense, depending on whether the ambulance is coming towards you or away from you. That effect is physically happening in the universe too. Galaxies may have very small motions which can give them that so-called Doppler effect. But this effect of the expansion of the universe is quite different and happens on very large scales. So what we need to do is to measure this redshift. So how do we do that? Well, we have to study the galaxy, the light signal that we get from the galaxy, and find some characteristic property of it. For instance, the fingerprints of hydrogen or carbon or oxygen that's contained in the radiation that the galaxy emits. And if we know in the laboratory what that radiation looks like at rest, then we can measure the shift and how far those fingerprints have been shifted.